The Ministry of Sovereign Intelligence, Agent 26, Sterling Vane. Real science, real stakes.
Vane, the whole eastern section just dropped 2 meters. The rig is going down, and I've lost the gyrocopter's terrain mapping overlay because apparently Bolivian altitude does not agree with firmware version 4.7.
Cooper, how long until the subsurface pocket collapses entirely?
My terrain AI says 4 minutes, maybe 3. It keeps changing its mind, which is frankly not what I want from an AI right now.
Sterling, Rios has reached the far edge. He has a vehicle. If he crosses the western crust before it sets, we lose him and the detonator codes.
The vehicles are already lost. The surface is in a liquid state. It flows under load.
So how are you walking on it?
I changed what the surface knows about pressure, Cooper. Physics doesn't care how expensive your vehicle is. It only cares about force per unit area. 9 hours and 4 minutes earlier.
Sloane, I need the Bolivia geological files, full package. Rios' entire academic record, the Atacama incident report, and the Meridian extraction survey from 2019.
Good morning, Agent Thorne.
Right. Yes, good morning, Sloane. I need
Biometric reclearance for sub-level 4. Files lapses every 72 hours. Yours lapsed yesterday.
That can't be right. I set a reminder on my smartwatch updated overnight and wiped the calendar integration. 3rd time this month.
I'll note that under recurring preventable incidents. Stand on the scanner. It says your palm temperature is too low for a confident read. Were you outside?
I biked over from the hotel. It's 3 degrees and the altitude is giving me a headache.
Revolutionary choice. Warm your hands on the desk lamp and try again in 90 seconds.
Sloane. Good morning.
You've got Moroccan spice market on your lapel.
Marrakesh. The previous matter ran long. I brought pastilles, the ones you mentioned. They're in the diplomatic pouch.
Sub-level 4 files are queued. The Dean is on the line.
Then I'm nearly on time. Morning, Cooper. Try cupping your hands. The lamp's radiant output is too diffuse at that distance.
Right, yes. How does he always... Oh, finally!
Vane, Bolivia. Dr. Mateo Rios, former senior lecturer in geotechnical engineering, Facultad de Ingeniería Civil, Universidad Mayor de San Andrés. He left academic life 8 months ago. He has been operating in the Salar de Uyuni for the past 6 weeks.
3 lithium extraction rigs have experienced catastrophic subsurface failures in the past fortnight. 2 Chilean, 1 German consortium. Each failure came without seismic warning. Each preceded a short position trade on Lithium Futures anonymous accounts, but the pattern is unambiguous.
He's triggering subsurface liquefaction beneath the rigs. The Salar sits on top of interlayered mud and loose halite saturated with brine. If you pump cyclic pressure waves into that layer at the right frequency, you build up pore pressure until the grains lose contact with each other entirely. The layer stops bearing load. Everything above it drops.
7 inches theory or in practice?
Rios turned it into practice. 3 times.
And the 4th target?
The Helios rig, largest single lithium reserve on the Salar. If it fails, the global supply shock lasts 18 months minimum. Rios has staked positions worth 900 million. He detonates at noon local time. That's 9 hours and 4 minutes from now.
The Bolivian authorities cannot reach the site without triggering the very sensors Rios is using to monitor approach. Conventional extraction is impossible. He'll collapse the rig early if he detects military hardware.
The salt flat ground conditions?
Top crust is solid enough at rest 40 to 60 centimeters in the target zone. Below that, interlayered mud and loose halite saturated with brine. Very sensitive to cyclic loading and weight distribution. Anything heavy or fast-moving causes flow.
Granular flow. It jams, too under the right conditions.
I've preloaded a terrain AI on the gyrocopter's navigation suite, and I've sourced a solar hover buggy for surface transit top of the line. It adapts its skirt pressure in real time.
Which means it applies continuous, oscillating downward force to a granular surface that liquefies under exactly that stimulus.
Is that bad?
That's very bad, Cooper. The gyrocopter is different turbocharged airframe, minimal surface contact. It'll get you close.
And for the final approach,
Rapid deploy mesh, military surplus originally for bridging soft Arctic terrain, and a weighted percussion rig. My addition to the kit.
your reading, as always, is impeccable.
Rios has a detonator. A redundant wireless trigger, he keeps it on his person. You cannot let him reach the western edge. The gyrocopter is fueled on the apron.
8 hours and 41 minutes later, Salar de Uyuni, 3,600 meters above sea level. The largest mirror in the world.
We're 2 kilometers out. I'm reading Rios' signal near the Helios rig. He's stationary, probably finalizing the trigger sequence.
Sterling, the rig's subsurface sensors just activated. He's priming the resonance emitters now. Estimated time to full liquefaction, 12 minutes.
Set me down 400 meters east of the rig. Surface looks stable there.
Vane, my terrain. AI is flagging the entire zone between you and Rios as Category 4 instability. That's the technical term for it will swallow you.
Not if I raise the surface above its jamming threshold. Conduit. Surface granule, median diameter at this location.
Estimated 2 to 6 millimeters. Halite crystal, near cubic habit, low angularity.
Sufficient packing fraction for jamming under compression?
At mesh distribution of 1.4 square meters per node applied normal stress, will be below yield threshold. Short, sharp compressive pulses will increase local packing fraction above critical. Force chains will propagate through the layer and lock.
Thank you.
Sterling, the emitters are running. Liquefaction in 9 minutes.
The hover buggy, I'm bringing it around to cut him off from the west.
No. Keep the gyrocopter airborne and off the surface entirely. The buggy will sink within seconds of touching the active zone. Cooper, stay in the air.
But I could.
He said, stay in the air, Cooper.
Staying in the air. He's walking on it. The terrain AI says the surface is in active flow and he's walking on it.
The mesh distributes his weight. The compressive pulses force grains together, building force chains that lock the layer above its yield stress. He's building a load-bearing path 1 meter at a time.
That's impossible. That zone is fully active. You cannot.
Dr. Rios, I have 9 minutes before this rig collapses. So do you. I suggest we discuss the detonator.
You're alone. You have no vehicle. There is no way across.
And yet,
He's stuck. The loose layer caught him. He doesn't have a mesh.
Sterling detonator. He still has the trigger.
conduit. Rios' position relative to my path.
11 meters. Bearing 273.
I have the detonator. Sloane the emitters.
Sending the shutdown code now. Emitters offline. Subsurface stabilizing.
So, the salt flat. The whole thing jammed. Like a bag of coffee that's been vacuum packed.
An excellent analogy, Cooper. Precisely like that.
And Rios just sank. Standing still, he sank.
He applied weight without distributing it. Without the compressive pulses to force the granules into contact, the surface had no force chain network, no load-bearing capacity. It behaved as a liquid.
Bolivian authorities have Rios. The Helios rig is intact. The financial regulators have frozen the short positions. The pastilles arrived in the diplomatic pouch. They're excellent for the record.
So I'll pass that along to the vendor.
Good work, Vane. Clean, quiet, enjoy the evening. There's a situation developing in Black Rock Desert, Nevada site of massive experimental installations.
Of course,
Does he ever just say, well done, take a week off?
No, and neither do you. So sit down and update your biometric clearance before it lapses again.
Right? Yes, absolutely. My tablet needs charging. Could I use your...
No.
granular jamming. A bag of ground coffee, vacuum sealed, is a brick. Tear the seal, and it pours like water. Nothing about the coffee has changed, only the pressure between the grains. Granular materials, sand, salt crystals, coffee grounds have no fixed state. They flow when grains can slide past each other freely. They become rigid when grains are forced into contact and locked together, forming what physicists call force chain networks that carry load through the material. The transition between flowing and solid is governed by one variable, packing fraction. How much of the space between grains is occupied by grain? Cross a critical threshold, roughly 60% for typical granular materials, though the exact figure depends on grain shape, friction, and size distribution, and the material loss. Rios understood this in reverse. He used cyclic pressure waves to build up pore pressure within the brine-saturated subsurface layer, forcing liquid between grains until they lost contact with each other entirely. No contacts, no force chains, no load-bearing capacity. The ground above simply dropped. The mesh solved the first problem. It spread my weight across enough area to keep the pressure per grain below the threshold at which flow begins. The compressive pulses solved the second. By momentarily squeezing grains together, they rebuilt force chain networks through the layer temporary, local, and entirely reliable. Loose, it flows. Packed, it locks. Same salt, different contact, different state entirely. Nature's laws don't care about your budget, your firmware, or your geology. They only care about how many grains are touching.